Hi, welcome back. I'm Rakesh Naik. Today we are going to discuss about topological sorting, which is a graph algorithm. But before we start, a small information I would like to give. We have been producing the same video in two different languages, English as well as in Hindi. You can identify that from the thumbnail. The main objective is that you can choose your preferred language to see the video. If you have not yet subscribed, please press the subscribe button followed by the bell icon so that you will get all the updates from this channel. Please support us by liking, sharing and commenting also. So let us start topological sorting. In a directed graph in which the vertices represents a task or activities and the edges represents the precedence relations between the task, we call the activity on vertex network. So topological sort is applied to the activity network to determine the order in which the task is to be executed, and topological sort is the process of assigning linear ordering to the vertices so that if there is an edge from vertex I to vertex j, then I appears before j in a linear order. There are two common algorithms we use for topological sorting. First one is by using depth first search algorithm and the second one is by source removal algorithm. So we are going to use these two methods to find the topological sorting of a particular given graph by taking some kind of an example. So let us start with depth first search algorithm. Now in this method what we generally do, if a graph is given, we find its depth first search. So we note the order in which the vertices become dead ends. The dead end vertices are popped off from the stack and written in the reverse order. Let us see the example. Let us say this is a graph given, and in this graph we found there is no cycle in the graph. So it is a directed acyclic graph. So the topological sorting is possible in this particular graph. So please remember, topological sorting is possible when the graph is directed and acyclic graph. We are using depth first search, so we need a stack. So the first vertex that we entered is vertex v1, the next vertex is v4, the next one is v6, then v3, v5 and v2. So in this way we fill the stack. And this is the depth first tree that we got. If we want to pop it, the first one will be popped is V2, then V5, then V3, V6, V4 and V1. And now if I want to reverse the popped up element, we'll get V1, V4, V6, V3, V5 and V2. So this is the required topological sorted list. Isn't it simple? So let us try to do one more example. Let us say this is the graph given and the stack is filled in this way. Because V1 and V2 are independent of one another, so we can write V1 then V2 or V2 then V1. It will not be affecting at all. So if we want to pop the stack, V5 will be popped first because it is on the top of the stack, then V4, V3, V1 and V2. And if you want to write in the reverse order, V2, V1, V3, V4 and V5. This is the topological sorting based on the depth first search. So let us try to see the steps that we are going to use for source removal algorithm. So in this what we are going to do is, if a graph is given, we are finding the vertices with no incoming edges. Delete the vertex along with all its edges outgoing from it. If there is more than one such vertex, then choose randomly. The second step is note the vertices that they are deleted and all the vertices give a topological sorted list. Let us do the same example here. This is the graph given and we are using source removal algorithm to find the topological sort. Now here V1 is the vertex in which there is no incoming edges. So we are going to delete vertex V1. Along with that we are going to delete all the edges. So V1 is a component and the rest of the graph becomes one more component. Now we want to find those vertices where there is no incoming edges. So V2, V3 and V4 are the three vertices where there is no incoming edges. So anything in any order we can choose, we have to choose randomly. So we can start with V2, we'll delete V2, and along with the vertex we will be deleting the edge. So there are now V1 and V2 as two components, and the rest of the vertices are one more component. Now if we want to delete V3, so the graph will look like this, and if we want to delete V4, the graph will look like this. So the order in which the vertices are deleted are V1, V2, V3, V4 and V5. This is the required topological sorted list. Isn't it easy? Let us try to do one more example for better understanding. So this is the graph given. Here you can see V2 is the vertex where there is no incoming edges. So we'll delete V2 first, and this is the graph that we'll get. Now we'll take this graph as input and find the vertex where there is no input line. So here vertex V1 is having no incoming edge. So we want to delete vertex V1 and our graph will look like this. Now here vertex V4 don't have any incoming edge. So we'll be deleting vertex V4 and the graph will look like this. And there is no incoming edge for V3. So if we want to delete V3, this is the vertices we'll get. So the required topological sort is V2, V1, V4, V3 and V5. Thank you for watching this video till the end. Keep watching, keep learning. If you like the video, kindly give a thumbs up, share with your friends, and please comment about the video. We'll make in one more video. Till then, take care. Bye.